Hello everyone, hope you all have started enrolling for the examination. You just need to sit back in home. You can give your exam from your mobile, laptop, tablets, whatever you use, whatever device you are comfortable with. You can give exam from there. So I hope you all are enrolling. Do enroll and keep going. Next, today we will be starting periodic table, but two more questions which we did not discuss previous day, which are left. Let us discuss that one. Question number 21. Till 20 we discussed that homework I gave. So this question is telling an element X has 2 electrons in its M shell. It forms bond with an element which has 7 electrons in its third orbit. Now X has 2 electrons in its M shell. That means K and L must be completed. So 2, 8 and it has 2 electrons. That means 2, 8, 2. The configuration is 2, 8, 2. In this way you can write in the rough work 2, 8, 2. And 7 electrons in the third orbit means it also has 3 shells KLM 2, 8, 7. So basically they are talking about magnesium and chlorine, but as they have mentioned X and Y, you are not allowed to write magnesium and chlorine anywhere in the answer paper. This kind of question is very popular in council, and also we give this kind of question where you know the atomic number, but then also they represent the element in terms of X and Y, A and B, and it is strictly says that when in the question paper they are providing you a symbol, you cannot write your own symbol. Like in the unit test, it was provided, atomic weights are provided. In spite of that, you tried to cheat and got your answer in fraction, which is impossible to get from whole numbers. Similarly, you cannot use the term magnesium and chlorine here. So I will also use the term here X and Y. Write the formula of the compound form. So X is having 2 electrons at its valence shell. That means its valency 2. Y has 1 electron at its valence shell. So its 7 electrons at its valence shell. That means it will accept 1 electron. So Y's valency is 1. X will lose electron. It's a metal. Y will gain electron. So it's a non-metal. So the formula will be XY2. Which nearest inert gas electronic configuration will X and Y will acquire? See, X has 2 electrons at its valence shell, so it will lose 2 electrons and it will have 2,8 electronic configuration, which is neon structure. Whereas Y will accept electron, it will form 288, so it will have argon structure. So 10 electron structure and 18 electron structure, helium, neon and argon. Show by orbit diagram formation of X and Y. This you all do. It's similar like magnesium chloride, but then again I am telling, do not write Mg and C. Question number 22. In the formation of oxygen molecule 1 it is given and carbon tetrachloride molecule, state the following. That means you need to answer all these 4 based on these 2 molecules. Electronic configuration of nearest inert gas attendant. For oxygen, the nearest noble gas attendant is 2,8. That is neon structure. For carbon tetrachloride, chlorine has acquired the argon structure 288 and also carbon has acquired the octet structure 288 by sharing. Oxygen also has shared electron. How many electrons are shared or transferred in the bond formation? Oxygen has shared 2 electrons per atom. Always say 2 electrons per atom. Per atom you need to mention. Carbon has shared 4 electrons per atom. Only 1 atom it has. Chlorine has shared 1 electron per atom of it. Which type of bonds these compounds forms? Covalent bonds. Draw their orbital diagram. So you can draw the orbital diagram. So these about some question answers. Will be revising, keep revising this question answers as well. These are the certain types of question that come from here. These are basically application based question. Next chapter we have periodic table. To give you a brief about this periodic table chapter, what we have in the syllabus. Again, to tell you the syllabus of the periodic table, I have the syllabus. Those who cannot download, just follow what is there in the periodic table chapter. Basically 118 elements you need to present, or you need to tabulate in such a way, in a scientific way, in a systematic way, so it will become very easy for the scientists to learn, to understand, because it is not only mugging up the name of the elements that will not help you out. Basically, if you have a scientific approach or distribution, proper regular distribution, so if you study about a particular atom, the nearby atom's property will be known to you all. That is just the basic motto, and this concept was started long back when there were a number of atoms which started discovering, when there were 64, 68 elements were discovered, then scientists automatically in need of getting such approach, such such scientific approach or scientific method to distribute the atoms, or systematic approach, so that it will be easy for study. So the topics that we have in the syllabus, I am just reading out the syllabus that we have. Joubert-Reiner's triads, Newland's law of octaves, Mendeleev's contributions, modern periodic law, the modern periodic table, groups and the periods. That means this is a gradual formation or gradual growth in the periodic table. Today the periodic table that we learn, that we study, that is a long form of periodic table, but Rome is not built in a day. So a lot of history is there at the back to achieve this success. So we are going to read these 3 stepping stones to achieve the milestone. And then general idea of Joubert-Reiner's triad, that means in detail. First line they have written the topic, and then in detail what you need to read. General idea of Joubert-Reiner's triad, Newland's octave, Mendeleev's periodic law. These 3 are the most important parts in the history of making periodic table. That means you need to know the basis of these theories, the laws, the faults of the laws. That means fault means the drawbacks which needed them to overcome, or which made to make another new one to go for. That means drawbacks and overcoming the drawbacks through the next law. Discovery of atomic number and its use as a basis of modern periodic law. Basically, actually Mendeleev is called father of periodic table, because today the long form of periodic table that we are studying, that is basically given by Mendeleev. The idea is of Mendeleev. Mosley just changed atomic weight to atomic number, and then those basic problems which were there were solved. So those solved problems were basis of atomic number. So we'll study why that problems and how the problems were solved. Next is discovery of atomic number. Already I have said modern periodic law, modern periodic table, group 1 to 18 and periods 1 to 7. That means you need to have the idea what is a group, what is period, how many groups, how many periods, what are the names, general names of them, how they are arranged. Then special reference to alkali metals. We will study bit about alkali metals, that is group 1, alkaline earth metal group 2, halogen group 17 and noble gases group 18. So you have only these 4 groups, idea of these 4 groups. We have different others like nitrogen, chalcogens, halogens. We call group 17 as halogens. Then actinides, lanthanides, transition elements. So many features are there of the modern periodic table. But our focus will be based on these points only. And periodic properties, which is atomic radius, electronegativity, ionization potential, electron affinity, metallic non-metallic character. These are the properties which are called periodic properties because they repeat at a certain interval in the modern periodic table. And if we read about this general trend of the properties, we can get the idea of the entire table, how from left to right or top to bottom these properties are actually varying, and these helps in understanding their chemical properties as well. But we have periodic property in class 10. In this class, I will talk about 2 periodic properties which are related to your old chapters, and that is why I will just highlight those 2. That is electronegativity and metallic non-metallic character, because metallic non-metallic character idea you all have. So just an idea, I will give a periodic property based on these 2 factors. And about electronegativity, already we had a discussion during polar non-polar character. So we know that elements which are nearest to the near to the noble gases, they have a tendency to accept electron. They try to attract electron pairs always towards itself in a combined state, which is actually the definition of electronegativity. And electropositivity, this term we apply for metals. So as these terms are related to the bonding, related to the atomic structure as well, that is why atomic structure, water chapter, these chapter, all chapter related. So these 2 I will take as reference while explaining the periodic properties. So next day I will continue with this chapter, periodic table. We'll start with the history. We'll start with Joubert-Reiner triads and then law of octaves. and gradually we'll proceed with the chapter. Parallelly, some question answers we'll discuss from the atomic structure chapter as well. First 3 chapters you gave and the unit test. See you in the next class. Till then, take care and bye.